All right, so as I said earlier, this is our first session, our first lecture in advanced database management. That's my email address, so feel free if you have any queries to send me an email at that address. Now, databases. Can you share with me at least 2 applications that you have used that involve a database? 2 applications that you would have used since the start that involve the use of a database.
All right. So yes, sir, I'll take that question.
Okay.
So WhatsApp is an application that uses database because it keeps track of the different accounts of numerous people across the globe. So WhatsApp is one.
All right. Yes. All right. So WhatsApp is one. Anyone else?
Sir, I would say Google Photos is an application, is that one?
So the,
Because does it take, not only does it stores photos specifically of you, but it stores photos of places, flowers, and anywhere else you've been.
very good. All right. So you're correct. So different applications. There are many applications in use today that are tied to a database. Um, a simple questionnaire, online questionnaire, is a database. It may be tied to a database. So oftentimes we complete online surveys and so forth. We enter information, and this information is normally captured in a database and so on. We have WhatsApp, as you guys mentioned earlier. We have Twitter and all these other social media applications. Most of them are connected to a database. So the truth is, databases are all over the place. They are being widely used, and database is actually what make social media what it is today. Now, in terms of reference textbook, this is a book that you may find helpful. Database System, the complete book. If you do a good Google search, you may find a free PDF version of it. There are other books that we have here, like a first course in database system um, by Jeff Ullman. There are other readings that we encourage you to do. Now, there is a reading on this website that is displayed on your screen, SQL for Web Nerds. We expect you to go through this document for next week class. We will have some discussion around it, so please spend some time going through that. All right. Now, in terms of the outline for today, we're just going to look at in general what a database is. I'm going to compare the database with the computer file system that programmers normally use, and we're going to see why databases are necessary. Now, by definition, a database may be viewed as a collection of related files. Now, the database management system is that application that is used to manipulate or to manage your database. Normally, database management system is a program. Sometimes this could be like a C program, which is used to manipulate data that is stored on your system. Now, the database brings to the fore a certain level of organization. And because the database allows for a high level of organization as it relates to data, it also increases the level of efficiency that is available when you are retrieving the data. So not that the data is stored in an organized manner, but because it's stored in an organized manner, it can be retrieved quite easily when you're using a database management system. Now, our focus for this course will be on what is called a relational database. So we are going to be creating a relational database. So we're going to be looking at things like entities and tables and so forth. So we're going to be storing our data in tables, and we're going to look at how these tables are interconnected and so on. All right, so as I said earlier, we'll spend some amount of time looking at modeling. All right, so there are various database management systems. From your studies, from your understanding, what are some of the database management systems that are out there? What are some of the database management systems that you're aware of?
So one would be Microsoft Access.
Okay.
So this is a relational database that Microsoft uses to store different systems that have some sort of relationship or some form of linkage between each of these entities or objects. So
Okay.
we see here where Access could be an example.
All right, so Access. All right, let's hold that one. Any other one? Any other database management system? All right, so there are others. So we have like MySQL. So we have SQL. We have Oracle. All right, we have MySQL. We have Oracle. Those are two very popular ones. And the beauty about them is that they are free. Microsoft Access is used by a number of persons. However, Microsoft Access comes with a certain amount of limitation that you will understand better as we go along. Now, the database management system, as indicated earlier, it's just really a program that is created using a language like C, and it's used to actually manage your databases. All right, good. So there are many database management systems, but the one that is chosen is really dependent on the application that you are actually creating. All right. Those of you who may be doing some amount of web development, you may have used things like Firebase database, and this is one of those databases that support like NoSQL and so on. But you learn more about that as we go along. Now, where are relational databases used? Now, as I mentioned earlier, relational databases are found at the back end of most traditional applications. So when you go in the supermarket, you'd have seen the cashier using an application. What you're seeing there is the front end. You're seeing a nice application, something that looks similar to what you would have done in your web development class or one of your programming class. You would have seen an interface that the user interact with. Now, when the barcode of an item is scanned, where is that information coming from? Of course, it's coming from a database that is connected to the front end of the application. And so relational databases are found at the back end of most traditional applications. All right, so you go in the supermarket, there's an application. You go in the bank, there's an application that the teller uses. Of course, that application is tied to a relational database. You go to the airport, you're traveling. Of course, when you go to check your documents, the system is tied to a database. So the database works in a back end. So that is where the information is stored. That is where the information is pulled from. All right. Now, when you go on websites, you go on like Google or Yahoo. If you notice, wherever in the world you go and you access your email, you're seeing the same thing. Because in spite of where you're located, Yahoo or Gmail or whatever you're using is tied to a particular database. And so, because the database is centralized, then you will be able to access your information from anywhere, from any location. All right. Now, you have things like even your micro eCampus site. That is a database that is tied to a database, which is Moodle. Moodle is the application. So the Moodle use MySQL. So it is tied to a SQL database. All right. So all the information that is entered on the eCampus can be found in a database. All right. So the eCampus that we use is just a front end. It's just an interface that is provided. But the data itself that is stored is in a database. All right. So there are different applications, Twitter, you name it. They use databases, Snapchat, WhatsApp, and all these fancy social media applications. They're all tied to a database. All right. And these are some other applications that we are building. So if you're building an application to store information on student, course, professors, and so on, more than likely we're gonna need a database. Now, different persons would look at this in different ways. So somebody who is proficient at programming and file management in the programming may be thinking of creating files to store information on these entities. So for example, if you're gonna write a program to store information on students, then more than likely you're gonna want to create a student file. And in the student file, you just have maybe just the student information. And then you'll probably have a course file, and next you have like a professor file and so on. Or you could have like a teacher file and all of those. All right. Now, if you're writing this, if this is a program to be written in C++, at that level, it may seem fine to you to just implement this using the different files. So you could have like a student file that stores just the student information, or we could have a course file that stores the course information, a professor file, and so forth. All right. So this is what we would probably think of doing when you're doing our C program or Java program. But what are some of the drawbacks to this? What are some of the drawbacks to this? Now, one of them is that if you use file as it is indicated here, only one person can access the file at a time. All right. So to allow multiple persons to access the file, you'd have to go through the process now of writing codes to lock the file and to unlock the file and all of those things, depending on who is trying to access it. All right. So accessibility is one of the issues. So normally a database is accessed by multiple persons at the same time. So multiple persons may want to access a database simultaneously. Now, if you're using a mere file system, this is not possible. All right, and this is gonna run you into some problems. Now, the other thing is that if you design your application using a wide variety of files, different file types, and so on, it's gonna make things a bit more difficult for you, because if you now want to upgrade the system and you want to integrate it with something, you'd have to write code, a different set of code to read the course file, a different set of code to read the professor file and the student file. they may not necessarily be in the same format, and all of those things will cause additional issues. And so it will end up being inefficient. It will increase the level of difficulty that comes with simply accessing and upgrading the records. Now look at the example on the board, on the screen, sorry. Let's say we want to enroll Mary into a course. All right, so we'd have to read Mary's information from the student file and get the course information from the course file. So as you can see here, we are dealing with a wide variety of files. And in order to treat with a particular file, you have to write specific codes that can handle that particular file. For those of you who would have done file storage in your structured programming course, you will have an understanding of what I'm talking about. So different files come with different format. So as I said earlier, the student file is going to be different from the course file. And the files now may be all over the place, right? And if it's an organization, you may have the accounts department using a certain file format. You may have the admin department using a certain file format. And so throughout the organization, you have this wide array of file formats. And so now if we want to integrate everything, it's going to become so chaotic, so difficult to integrate everything. And this is what happens when you use a file system. All right, when you use a file system, it's more difficult to allow for multiple users to access your application simultaneously. Most of the systems that are based on file systems are single user applications. Single, in the sense that only one user can access the application at a time. Any question so far?
No questions so far, sir.
Are you following me? All right.
Yes, man, I'm with you, man.
Good. Right. So traditionally, applications were created using the file systems. And the truth is, if somebody writes an application using a particular file system, the data that is stored in that system is not easily transferable to other applications. So if I wrote an application probably for a medical information system, and I simply store my information in a file system, it becomes more difficult if that system is to be interconnected with, say, a health insurance system, as it is the case today. So most medical information systems are now interconnected to the healthcare providers. That is the insurance companies like Sagicor and so forth. And if the file systems are not compatible with each other, then the integration becomes rather difficult, right? And that is one of the reasons we actually encourage you not to use the traditional file systems, but it's better to use your databases. And of course, when the amount of data that is being stored gets large, and you have a file system that doesn't really organize the data well, it becomes more chaotic. All right. And another consideration is that if you have a certain file system on a Windows machine, that file system may not even be compatible with another operating system. All right, so there are so many different dimensions to look at as it relates to the file system. And so the database now comes in as a better alternative to the file system. Now there are two main tiers here as it relates to database, your database system. So we have the database server, and we have the files. The database server actually manages the files that are stored. That is why you're encouraged to install the MySQL server, all right? So the MySQL server, that's gonna work as our database server, and that is what we're gonna be using to organize our files, all right? So the database management system is so designed to organize your files for you. It makes organizing the files much more simpler than using the traditional file system, all right? Now your application that you're gonna be creating, that is your front end, will then interface with your database management system, all right? And that is how we actually go about storing our data. So think about WhatsApp for argument's sake. Now WhatsApp is the front end. The WhatsApp application is the front end that we interact with. When we send a message, that message is stored in a database. So the WhatsApp application that is on our phone is connected to a database. This database is stored at a location that the developers of WhatsApp determine. So that information is then sent to the database management system, and it's handled from there. So the application, as I said earlier, is connected to the database management system. All right. Now, in this course, we're not gonna actually create a database management system. But if you're doing a more advanced course, probably a postgrad course, you would be asked to create a database management system. So to create a database management system, you would use like C++ or C, or even Java to do that. All right. But what we're gonna be doing for this course is to create databases. So we're gonna be using a database management system, and the one that we're gonna be really using is SQL. Now, there are two main. Yeah.
So that means we can use brackets then, sir, in regards to creating the program for the SQL, right? Like,
You can, yes, you can use bracket to create a front end.
okay.
You normally use bracket to create like your web page, right?
Yeah, that's correct, sir. That's what we used in the previous course, Introduction to Database.
Okay, so
Web page design.
right. So your web page would be the front end.
Mm-hmm.
The back end, we're gonna be using like Workbench, MySQL Workbench, and so on.
Okay, understood.
All right, so there are two main languages of concern when we speak about database. When we speak about SQL, we have the data definition language. We have the data definition language, that's DDL, and we have the data manipulation language. So we have DDL, and this is what we would use to create like a table. This is what you'd use to create like the structure of a table. And I'll show you an example shortly. And we have the data manipulation language. And this is the language that we'd write to query our database tables or entities. All right, so there are two different languages. So you have the definition, the data definition language, that's DDL. And we have the data manipulation language. So one is used to define the data set. All right, so we can look at it that way. So one define the data set, define the structure of what is used to store the data. And that's gonna be your table. So one of the languages is used to define the table. So to say that this entity or this table should have these fields: ID number, first name, last name. ID number should be number, first name should be text, last name should be text, and so forth. Then the data manipulation language, that is the language which is used to actually query your database. So you're actually gonna have to write codes, simple codes to query your database. In Access, most of what you did would be done from an interface where you maybe just indicate a text below a particular field, or you put some simple expressions to achieve your queries. It will be slightly different with SQL, so you'll actually have to write a little more code. But of course, it's something that you'll find you'll have a lot of fun doing. All right, you'll always have fun doing these things. Now, behind the scene, this is not going to be much of a concern to you unless you're developing a database management system. We have the query optimizer, we have the query engine, we have the storage management, and so on. All right, so these are stuff that are implemented in the database management system. So if you were to write the C program for the database management system, these are the things that you would really be concerned with. But for us, our two main concerns are the data definition language, the data manipulation language. So those two will be our main concerns. All right. All right. So when you are doing your web design class, you would have been made of things like client server architecture. And this is basically a system where a client is connected to a server. So this is really the standard that is used for most applications. So we have a client, so like at the supermarket, the station at the cashier would be the client, and the station that has or hosts the database and things like the web server and the database server, that is the server. So there we have what is called a client server architecture. So within a client server architecture, we have a set of clients that are connected to a server. Now the beauty about this architecture is that we may have one server that serves multiple clients. So if we have a client server architecture and we want to implement a system, all that would be needed is for us to install the system on the server, and then we have the clients connected to the server to access the system. So pretty much there will be no need for you to be installing the system on your machine. Think about the micro eCampus. The micro eCampus is installed on one system. So it is installed on a server. The location of that server, we are not sure. But if we check with the online team, if they so please, they may disclose source where it is stored. But that's not a big concern right now. The thing is, the system is installed on one server, but we, who are the clients, can access it from or different locations. All right, so the micro eCampus there is an example of a client server architecture. So it uses a client server architecture. So the system, the module, or the eCampus, whatever you call it, it's installed on a server. This server could be located at Mike, or it could be located probably in France. It doesn't matter. But we who connect to it are like the clients. And this is what happens. So when I go to KFC, the cashier, the system at the cashier, that is just a client. And there's a server now that has a database with the prices, that maintains a record of the transactions for the day and all of those things. So the client is connected to that server, and so we have what is called a client server architecture in that scenario. All right. All right, any question? Now, the beauty about the client server architecture is that it comes with a certain level of efficiency. All right, so it allows for centralized storage, centralized management of our data. So if for example, the price of KFC two-piece meal is to be decreased due to the pandemic because the system is centralized. So if the price changes to say $500, you would not have to worry because it would be reflected across all their system because all the systems will be connected to that server. All right, so that's one of the beauty of the client server architecture. So if, for example, there is a video on YouTube and there is something to be changed in that video, once it is changed at one location, it's reflected across all the clients that access it. So with the client server architecture, we have a centralized storage of the data, storage and distribution of the data and so on. All right. So the application that you're going to be doing for your project will be based on the client server architecture. Now, as promised.
Oh, sir, question. Sir, so that's why I said it's good for storing data. Because once a change is made on the server, then it is reflected throughout the clients. That's why I said it's good for data.
Yes, it is. Yes.
Okay, sir. Thanks.
That's one of the many reasons, right? All right.
Okay.
Now, all right. So this is just a little preview. We're not gonna really be doing this just now, just for you to have an idea. So here we have an example of a data definition language. The beauty about queries, about SQL, is that when you read it, it sounds like you're speaking English. It sounds like your native language. That is why it is so easy. That is why you will all like it, right? So, I mean, everyone will like SQL. Both males and females will like it, all right? Some of the best database administrators are females, and of course, some of them are males as well, all right? Persons like Jennifer Widom, very famous for database management. And so I know that there's no bias as it relates to how well you guys will do as it relates to database. All right. So here's an example. So if we read this, we can actually get what it's saying. It's really natural language, so close to natural language, I would say. Create table student. So right there, we can tell that we are creating a table. All right. And we can tell what the columns are. So the columns in the table are going to be name, and it tells you what type of data name will store, social security number, what type of data it will store, and category and all of those. All right. So that's an example of a data definition language. So it's as simple as that. But you'll actually get to do it and not just mere seeing it. We also have, yes?
I was just going to ask, sir, is after you actually create this, the definition, this is what you use to upload into the server in order to get all the information accepted?
All right, good. So when you create, to do the definition of your data, you have to do it on the server. So you're gonna be working from the server.
Okay.
So when you create the database, it's gonna be on the server. When you create a table, it's gonna be on the server.
Okay,
so all
sir.
of these will be on the server. All right.
Thanks.
All of this will be done from the server. All right, but then now the application. So all you have to do with your application is to indicate in the application how to connect to the server, and you're good to go. All right, and we'll go through all of those.
Okay, sir. Thanks.
I don't know if you guys ever hear about SQL injection. It's a very common hack. Well, for those who are interested in hacking, common way to hack into people database if they are poorly designed. All right, but you'll learn more about that, especially when looking at data manipulation language. All right, so here we have a snip of a data manipulation language. So we have, what we are doing here is that we are inserting a record into students. And all we do to do that is to just say insert into, specify the table name, and what we want to insert. All right, so it's pretty much as simple as this. All right. All right, so now relational database normally represent or its data using tables. And so throughout the course, as we go about our design, we will see different tables being created. Now, while this somewhat mimic what a file may look like, in a relational database, the files are not disjointed. All right, the files are not, the tables are normally related. All right, that's one of the benefit of using a database over the file system. Because when you create your tables, the system allows you to establish, of course, relationships. So it will show you how different tables are related and so on. And so we will be able to manipulate multiple tables simultaneously. All right. But as I said earlier, this is just a preview of what is to come. Again, this is how we would go about inserting a record into a table called takes. All right. So again, we use insert into. All right. Now, the beauty about your database is that once a transaction starts, it will either be done completely or it will not be done. So this is one of the reasons when you go to the ATM, you can feel a certain level of relief when you perform your transactions. So for example, if you are withdrawing some money, it's either the withdrawal is done or it is not done at all. So if you are withdrawing money and something fails, the process starts, your card is taken away, you can rest assured that nothing will go wrong with your account. If the transaction is completed, it will be completed. It's either it is done or it is cancelled. All right. So there's nothing, no halfway processing that is done using a database. All right. So transaction, as it relates to database, refers to the sequence of statements that are either done completely or successfully or all failed. All right, so when we talk about a transaction, we're talking about a sequence of statements. Either they are done successfully or they all fail. So there is no in between. So if you go to withdraw $1,000, it can't be that the system start the withdrawal process and stop. How the databases are designed, if there's an error, it's going to cancel the transaction altogether. All right. If it is okay, then it will complete the transaction. So the transactions are either done completely or they are not done at all. Is there anyone who have ever had an experience where the transaction is done partially? So you're probably using your ABM, you're probably using maybe a card at the point of sales, and I mean, there's an error, but your money is still taken out of your account. Anybody ever experienced something like that?
Wait, sir, wouldn't the machine taking your card but giving the money, wouldn't that be a half transaction? Because something happened.
Taking your card,
Yes, sir, but you got the money.
you have had that experience?
Yes, sir.
All right, so was the transaction reflected on your account that you got the money?
Oh, yes. Yes, it was.
Right, so once it was reflected on your account, it was completed.
But
Oh,
sir,
okay.
can I ask a question? When you
Yes.
go to the ATM and you do a withdrawal, is it that you get the card before you get the money? So how is it that the ATM keeps the money and keeps the card and then pushes out the money?
Go again. Go again.
No, I was saying that if you go to an ATM on a general basis and you make a withdrawal,
Oh,
you get
oh,
the card before you get the money.
yes. Normally I get the card before the money.
Yeah, so I was just asking, how is it that a card actually retains and then money still comes out?
Right. So it could be an issue with the front end or with the actual ABM system, but the focus is on the database section. So the data, based on what Akil said.
No, I know, sir, but I'm just asking based on what he says, because I'm trying to figure out how does that apply.
Right. So there could be different reasons for the machine to take your card. I'm not sure what his reason was. I don't know if he know what the reason is.
Okay.
All right. But there are different reasons
I
why.
don't see that as a realistic event. That's why I was asking.
It's based on the sequence that you described earlier.
Yeah, that's what I was asking. So, Mr. Clay, was that really an event that happened, sir?
Yes, it actually happened. Which account again? The DMBS. So what happened was that the card actually came out, but I didn't take it.
Oh, it came out and you didn't take it. Oh,
Yes, yes, sir. But the
oh,
money came out as well. So when I took the money, there's a time limit to which you should actually take out the card. So I
oh.
didn't reach in that elapsed time quickly enough. So I took back the card.
Yeah, I think that's a
And
security feature.
yes,
That sounds like security because yes, the money will be dispensed, but of course, maybe the system is one. Then what happened to you, and maybe for your safety, they take back the card. It could be a security issue. I mean, something that was implemented to add to the security. All right, good.
okay, sir. Yep.
Now, so transactions as it relates to database, this is something that you need to remember. Remember this acronym. Transactions in databases are said to be ACID. They have the ACID property. So transactions are said to be ACID. So we have they're atomic, they're consistent, they're independent, and they're durable. Now, by atomic or atomicity, we're saying that the transaction is either done completely or it is not done at all. So that is a guarantee. So that is one of the reasons we can have a certain level of comfort using these systems. So the transaction in the database is either done completely or it is not done any at all. And that is what we call atomicity. All right. So it's either the transaction is done, it's like in the human, like in the human world, somebody might say I love you, but they probably don't love you. But in the database world, if the database say I love you, it totally love you. All right. And if it say it doesn't, it means it just doesn't love you any at all. It's either the transaction is done completely or it is not done at all. That is atomic. And consistency, it simply means that the database will perform the same way at all times. So it will not treat with any transaction different from how it normally treat with others. So it will always be consistent, all right? And it is independent. So each transaction is treated independently. So 1,000,001 persons going to the ATM. John Brown's transaction should not affect Peter Brown's transaction. So each transaction is treated independent of each other. And there should always be durability. And durability speaks to the level of integrity that is maintained with the database in the sense that whatever state you leave your transaction in, you leave your database in, it should remain in that state until you would have modified it. So I keep using the ATM scenario. So if you leave $100 in your account, your database is showing that your balance is $100. You should always go back and see the $100. All right, so the data shouldn't change. So there should be no situation that actually change. So if you go and you realize something unusual in your account, now you're gonna be thinking, is it a case that my system was hacked or something went wrong? All right. So the ACID property should be maintained for each transaction in a database. All right. So it's either done completely or none at all. It should be consistent. Yes.
Back to independence, is it that's why if you're paying a light bill on the ATM and then you want to withdraw, that's why you would have to take out the card after one transaction, then put it in again?
Well, I guess that's how that particular bank set up their interface. The truth is we could enter more than one transaction, but of course they could be done separately. All right. So you're right in bringing up that example, because even if it allows you to put in the light bill and the water bill transactions, they would all be treated separately. They would not have, one would not affect the other. All right. So that's an example. All right. So each transaction is independent of the other. All right. And the transactions we're talking about, they're not always gonna be, say, financial transactions. All right. It's just different operations that goes on in the database. All right. Any other question? All right, so we can do queries. Queries can be done to search for information in our tables, to retrieve information from our tables. Queries can be done on one table as well as on multiple tables. And this is the basic structure of what a query looks like in a database. So we have like select, from, where. All right, so all of these we will go through in our upcoming sessions. This is just giving you an illustration as to how the different tables are connected to each other. So right here we have 3 different tables. We have our student table, our takes table, and our course table, and they are actually interconnected. All right. All right. All right, so most commercial systems use database management systems like MySQL Server, Oracle. They are free database management systems, and for our course, we're going to be using one of the free ones. So we will be using MySQL. All right, so there are other free ones, but our focus will really be on on MySQL. All right, so these are just some of the different systems, different database management systems. All right, the truth is, once you know one of them, you pretty much know all of them, because the idea, the concept behind them are pretty much the same. All right. There are some new trends in databases. We have things like object-oriented database. We have XML. We have NoSQL databases. I don't know if you're familiar with like Firebase. There are different ways to implement your databases. And of course, this course will allow you to do some amount of research so you can have an idea as to where database is going. All right. These days, you would have heard about things like big data, because we have very large data sets. How is it that we go about handling them? What sort of database technologies behind those? These are some of the things that we will be speaking more about as we go through this course. All right, and that's pretty much it. So this is what your, well, we mentioned this already, but your breakdown in terms of your assessment. Now for your reading, I would have mentioned a link earlier that I want you guys to read about SQL nerds. Let me just find that link. Right. SQL for web nerds. I want for you to access this web page, and you are going to read up on SQL. And I'll be posting some discussion questions on the Micro eCampus page that I do expect you to participate in. All right, so we will wrap it up here for now.